Hey guys, this is Willem here. I just wanted to give you guys an update on what we're doing at Terran One. So I've been working on this for the past 6 or 7 weeks, kind of nonstop, but I've given some hints about what it is on Twitter. And today I'd like to just give you a demo of what this can do and what you can expect within the coming weeks. So this is CWScript, and I've been working on the compiler. So CWScript is a new scripting language for Terra, allowing you to write smart contracts, CosmWasm smart contracts in a language that is simpler, easier, allowing you to express more complex ideas and play around with, just anything that you want without having to go through the boilerplate or the ceremony of creating a Rust contract. So the goal with this is that in the future, people won't have to learn Rust, or people won't have to necessarily use Rust to prototype ideas or to validate whether or not this could work on a smart contract or whatnot. All right, let's get into it. So I've actually, I've created a VS Code extension, and I'm actually working on a couple translations of contracts from TerraSwap. I don't know what that is. TerraSwap, I'm trying to translate a couple. And right now I have been working on the CW20 base contract that you can find in CW or CosmWasm Plus. So as you can see, the syntax kind of reads, it's very legible. It's actually inspired a bit by Rust, by Solidity, But the great thing is that it all compiles to CosmWasm, and it follows the CosmWasm semantics. So you get all the benefits of the security without sacrificing on, when you can have a language similar to Solidity without the shortcomings of Solidity, because CWScript actually compiles to CosmWasm. All right, so I think one thing I can show you is if I create a whole new contract. Let's do the CW template. So CWS is the file extension. So if you look at the contract of the CosmWasm template, I can actually just grab that here. Give me a sec. Let's see. Well, actually, let me just get it locally. So cargo generate, get CosmWasm CW template, and then we'll get the branch 0.16 because that's what Terra's on, and then we'll call this test contract. All right, so I think test contract should be generated, and we can see it. So this is, as you can see, there's quite a lot of files. It's designed to get you up and running with CosmWasm, but this is quite intimidating. There's a lot to do, updating a simple variable requires you to make a closure, and then do this thing with the result, and then you need to create a response. And as well as the execute messages, they're littered throughout a couple of files in the message. So when you need to change the functionality of your contract, you have to be editing multiple files, and that's an opportunity for human error. So what I've done is I've kind of created a way to canonicalize the representation of a contract, and formalize some semantics into a subset of Rust, and then expose that through a language. And let me just show you now. So I'm just going to put this on the side so then we can have it easily translatable. So this contract, let's call it, contract CW template. So this is contract keyword. Okay. So the first thing is we will need to define the instantiate message. So the instantiate message, takes in instantiate takes in account. Here it's an i32. But you know what? I'm just going to put this as a like u64. And we have execute messages. So we use the exec keyword, increment, right? That doesn't take any arguments. Exec reset, that does take an argument. I'm just going to be using u64 instead of i32, just because I have yet to translate the signed versions. Okay, and let's see. And we have a get count, no, query get or get count here, and there's something called the count response. So something cool that I've introduced is the ability to make inline type definitions. So you can do this inline, and it will kind of automatically, add that as a type in the contract namespace. All right, so now let's kind of fill in our contract implementation. So instantiate, oh yeah, I need to define some state variables now. So let's check out the state. So it seems that there is something called state, and then there is something like this. Okay, so we have the state and it's in a singleton, but I'm just going to do something like, I could make it a singleton. Like I could make it, state would be a struct here again with the inline type definitions. So I could either do struct state and do count u64 owner address, but and then what I do is I do this, like struct is state. But I think that's a little confusing, so I'm just going to put that, state here. So we have just the state is accessed through two variables rather than one variable that, contains everything. All right, so it's quite simple actually. So the first thing you want to do is maybe just do, let's just set state.count is equal to the initial count, right? That is a variable taken from the context of the message. And then the next one is I want the owner to be message sender. See, like GitHub Copilot is learning CWScript. That's pretty cool. Okay, increment. What does increment do? Increment just makes state.count equals state.count plus 1. And reset, I think it just state.count equals 0. Or no, just set to count and get count. I just return a count response, and count is state.count. So I've not added those, authentication checks because I'm still in the process of translating statements. But just to give you an idea of what CWScript looks like, you can actually code nearly all of the CW template contract in, like I just did with a few lines of code. And you know what? Let's even just add something that doesn't exist here, which is the get owner. So get owner, just to show you how easy it is to add an extra message. So it's going to be owner response, and then owner header, right? Then owner response. We change it to owner and state.header. Okay. You've noticed that I've also made some changes just to be a little bit, I didn't want to do like kind of weird, like message info and then message sender. It's kind of weird. So I will post up the API, but I've made some I've taken the liberty to make the API a little bit more like Solidity, so the Solidity developers will come in more easily. But yeah, so now we have like a full contract, and let's try to compile this. All right, I think this is set up right. So yarn CWSC is the name of the CWScript compiler. I'll be releasing like a playground and preview in the coming weeks. So yarn, and the file that I want is under examples CW template, src. No, CW template, CW template.cws. All right, let's try to compile this. Okay, it's compiled, and you see I have a new sort of crate. So every contract compiles to a crate. If you have multiple contracts, then you want to create a CWSC project, which will group together multiple things like I have here. So CW project shows that you have multiple crates, and I can configure things like the tools, like generating documentation, generating client libraries. So it's going to be possible to manage both individual contracts as well as, contract projects with multiple contracts and multiple dependencies and deep configurations. So I'm creating also like a sort of cargo for CWScript. All right, now let's check out the compiled output to see like what does it look like, right? Probably curious. So rather than having a bunch of files, I have put it all in one file because you can do that. lib.rs. So lib.rs, here's what the compiled output looks like. It's kind of ugly, but luckily we have Rust format. So basically we divide up the, contract into multiple types, multiple modules, and it follows the CosmWasm convention of, separating into module, the module message, state, error, contract. And you might notice that I've also the generated code uses absolute crate references. That's, to save up on the use crate, so direct dependencies. And it's a bit explicit, see, with the SCD results rather than just result. It's a hallmark of compiled code. As you can see, the code isn't exactly what you would write as a human being, because it's compiled, and it is compiled to a subset of Rust that is formalized to be safe and works with the ownership and borrowing. Also, so you can see that it creates the different parts in the different files, and the implementations for the query, the implementations for the execution, the multiplexer for the execute message. So it's not too far from the convention. I wouldn't recommend that you read it. You can maybe check that it is correct, but yeah. So I've also included a build script which allows you to build it. So I'm just going just make sure that it compiles and whatnot, because it would not work well if it didn't compile, right? So I think build debug. All right. Okay. All right. This is, yeah, okay. Template, get owner. All right, what is it here? 2 binary. All right, so it seems like there is a little bug. Oh, wait, what? No. Hold on. Oh, here we are. The adder. Okay, here. Okay, here is what is wrong. State. Ah, there it is. Okay, so I have yet to add some static analysis, but that's coming because, you know, you can just I have a compiler intern right now who's going to be writing those validations for me. But yeah, this is cool that, you know, at least it's sane. Let's do CW template, CW template.cws. Yes. Oh. Examples. This compiler is actually quite fast. It's just every time it has to, you know, I'm using TS node and it has to, it's actually TypeScript that's slow. But once it's compiled to JavaScript, it is quite fast. So let's go to CW template and build. All right, there's some extra parentheses, but you know, it's kind of hard to predict. So it doesn't hurt the build, but okay, now we've built successfully and we can see the output in this WASM file. So let me just reveal in Finder. Yeah, so then you can see that the output is not too far from what you'd get with just plain pure CosmWasm. That's because there's actually very little overhead that CWScript introduces. It's actually all the abstractions you see in CWScript are zero cost, following with the philosophy of Rust. There's a CWScript abstract machine, and that kind of computes things like static analysis and then figures out, you know, what is the right thing to do rather than, you know, put in a VM inside the contract. So anyway, yeah, there you go. That's a CWScript. And I would upload this to testnet, but I've been trying to do that for about 10 minutes. It's still stalled for some reason. Yeah, it's time for me to sleep. And happy hacking. See you next time. And delegate to Terran One to support ventures like this. Thank you.